Shall we start now, sir?
Are you getting my voice, ma'am? No? Yes, I just want to ask whether um, it should be, I should switch on my video or just audio will be okay with presentation on the screen.
Both are, sir. Which one you
Okay.
prefer?
Okay, so both are there, so I am okay. So shall we start, ma'am, now, or we should wait for other audiences?
Just 5 seconds, sir. Shall we start now, sir?
Yes, ma'am, we can start.
Hello, everyone. Present here virtually, I am Pallavi here, and I welcome you all for today's session, which is titled as Blockchain Technology and Cryptocurrencies. And presenting this session, we have with us our today's experts, Dr. Anuj Singh, sir. Dr. Anuj Kumar Singh, sir, working as professor in School of Computing at University of Engineering and Technology, Roorkee, India. He is also a postdoctoral researcher at South Ural State University, Russia. He has more than 18 years of teaching experience in technical education. He holds a PhD degree in the field of computer science and engineering from Dr. APJ Abdul Kalam Technical University, Lucknow. He passed M.Tech degree with first distinction from Punjab University, Chandigarh, and B.Tech degree with first honors from UPTU, Lucknow in computer science and engineering. In addition to this, he has also qualified UGC NET, having published more than 35 research papers in journals and conference including Scopus and SCIE. Without wasting much time, I am welcome to Dr. Anuj Singh, sir. You may start now, sir.
Yes, thank you, ma'am, for nice introduction. Let us directly go through the content of this webinar. The title I have selected is Blockchain Technology and Cryptocurrencies because as we know that a lot of cryptocurrencies have arrived now in the market, and like Bitcoin, Ethereum, Litecoin, many are there, and obviously they are built upon the platform that is known as blockchain technology. So all cryptocurrencies we can see on blockchain technology platform, and why what is the importance of this area and why we are studying it, that will be clear through the webinar. So if we talk about the presentation contents, first we'll understand the what is blockchain, the definition, mechanism of blockchain, how it works, the problem of double spending. That means what was the need of having this kind of platform, blockchain? Because earlier we were having many distributed systems. So why blockchain is there? Then we will see how Bitcoin has evolved to solve double spending problem. Its inception, how it was, what are the features of Bitcoin, and two important fundamentals that we need to understand, that is public key cryptography and hash functions, because both are the fundamentals behind blockchain technology for securing different keys in different systems. Then we will see what is mining. Then proof of work, we will understand what is the concept of proof of work that is used for consensus. Merkle tree, that is fundamental behind this reducing the size of the blockchain. And finally, different cryptocurrencies we will have a look. So these are the this is just an overview of the webinar. So let us start to understand that what is blockchain actually. So in simple terms, it can be defined as immutable and distributed ledger. So if we talk about this particular phrase, immutable and distributed ledger, there are three terms. First is a ledger. So ledger is a collection of financial accounts or transactions, like just like the passbook of bank. Like here is an example. Let's say for example, there are two entities, Kim and Joe. Kim wants to transfer $30 to Joe. So that this record of transactions is maintained in a particular ledger. That is a financial document. Immutable, that means it cannot be changed. So once a transaction has occurred and it is accomplished, then that cannot be changed after it is executed. And distributed means it is decentralized. So decentralized here, we can also refer to the, like say, banks are decentralized system, but in fact here decentralized or distributed means that is not controlled by a single entity. Like if we talk about banks, if we talk about their distributed systems, uh, implementation is based on distributed systems, but how we are saying they are decentralized, they're not decentralized because they are controlled by a single entity. Like in India, for example, we can take the example of RBI. But if we talk about blockchain is a kind of decentralized distributed system which is not controlled by a single entity. And last one is transparent. So if we talk about this transparency feature, that is very, very important to understand. Uh, Taking the example of bank, if I say or I put a question that are banks are transparent systems? So in my opinion, I will say no, because if, let's say for example, if I am having some certain amount with me and I want to deposit in my account, let's say 10,000 rupees I'm depositing, what the bank is doing with those 10,000 rupees is not known to me, or what other transactions which are other than my account, other you can say which are not related to my account, bank, whatever transactions are executed in a day, that means huge number of transactions are being carried out by banks. So banks are not telling every customer what is going to happen with the money, how much money they are taking from users account, or how much money they are investing, how much interest they are earning, what is the total revenue. They are not sharing these details with the customers. So in that case, we will say that banks are not transparent. But if we talk about blockchain systems, blockchain is transparent. That means every transaction which is happening over the blockchain platform is visible to each and everyone in the network. So that is the meaning of transparency. That means every transaction is, or everything, say for example, a new block is created or a new transaction is created, then that should be visible to the entire network in the blockchain or to every user in the blockchain. The question comes, why blockchain should be there, or why blockchain should replace the other distributed systems? So the reason is there are short, if we talk about financial transactions, because the topic we have selected is related to cryptocurrency and financial transactions. So we'll be discussing in that context only. So why blockchain? Because there has been shortcomings in existing transaction mechanisms, like uh, uh, they need third party validation. Let's say, for example, any dispute occurs. So what we need a third party. Like if we talk about bank, let's say two persons are uh, there is a dispute between transaction, or dispute in a transaction between two parties. Let's say party A and B. So that dispute can be resolved by a third party. So we need a third party for validating and verification of a transaction. Second is limited transaction size. If we talk about size of transaction within the bank, then it is limited. And if we talk about increasing the size of transaction, that means the cost of the transaction is going to increase. So it is direct, or you can say the cost associated with each and every transaction is directly proportional to the size of size of the transaction. Second is trust model is weak trust model. That means, like say I told, we have taken the example of bank. Bank is giving our money to whom, or where the bank is investing our money. That is not known to us. That's why we say that it is a weak trust model. And last is frauds and cyber attacks. We have seen that in past few years, especially last 5 years, you can see that there has been lot of rise in different type of frauds and cyber attacks. So these are the shortcomings in the existing financial or transaction mechanisms, and how blockchain addresses these by introducing peer-to-peer network, because we know that blockchain is a peer-to-peer model for making transactions. Reduced cost. So reducing the cost is very important factor. And why the cost is reduced? Because we are removing intermediary party or third party in the communication. That means if two peers, let's say party number one and party number two, they can communicate directly without involving of the third party. Without including this third party, these two parties can trustfully validate each other and increase trust. Trust is increasing because everything is transparent. Because if we talk about trust, the system that can be trusted where everything, each and everything is transparent and not hidden to anyone. So these are the reasons that blockchain has come into the picture. If we talk about the applications of blockchain, there can be numerous applications of blockchain that we can find in finance sector, like cryptocurrencies are there, in retail sector also are there. Like say, for example, we are building some contracts that are possible through the blockchain. In construction, we can also, or you can say, in real estate sector, energy sector, healthcare we can implement, supply chain, or what we should say that almost all kinds of distributed systems we can apply blockchain technology. So it's an emerging technology and the future scope is very wide. And why it is so? Because it is more secure and distributed form of data management. Coming to the mechanism of blockchain, so there are few terminologies. So what is a node actually? Here one term is node. So each individual who contributes to, yes, each individual who contributes to the blockchain network is called a node. And every node is having the same copy of the ledger. So that's why it is known as transparent system, because whatever entire content of the blockchain is available to each and every node in the network. And that is why there is a need for synchronizing that each and every copy of the blockchain across the network. So that's why we are saying that the ledger data hosted should be hosted and must be synchronized among all the nodes in the network. So here, if we talk about the what should be inside a block of blockchain. So here are three things. This is a block that we have shown. Number one is data and timestamp. What is data? Data is nothing but the actual transactions that are occurring, along with when the transaction has occurred and the time. So that time, data and timestamp is one input to the content of the blockchain. Second thing, if we talk about the chain, blockchain is chain of blocks actually, and how chaining is done. Chaining is done using the hash code, and that's why we will say that two more inputs or two more content of this block will be the previous block hash and the hash of current block. That means this block. So hash of current block means whatever is inside this block, the contents are being hashed. We will talk about hash also here in this particular webinar. So blockchain is a peer-to-peer network of nodes that we have discussed already. And a block is containing, what it is containing? Data about transactions. That means, let's say Kim and Joe, we have taken the example. So Kim has transferred $30 to Joe. So that will be recorded along with the timestamp, hash of the previous block, because it is going to be changed with the previous block, and hash of itself. Now, hash of itself will again be forwarded to the next block in the blockchain. And what each block does, it records some computations. What are computations? Nothing but transactions. So this is just the structure or schematic diagram of a node or block in blockchain. So if we talk about blocks, blocks are actually ordered in the network of non-trusted peers. Non-trusted, why we say, because no authentication is performed actually here. Authentication is it is done by using public key mechanism. That is different we will aspect that we will talk about later. Now here we can see the hash. How chaining is done. The hash of current block is going to be chained with the next block. So if we talk about, let's say block number 1 is there, block number 2, if we talk about, block number 2 is taking or is having the previous hash block as this one or the previous block hash, and current hash is marked as hash only. So this is how the chaining is done. And each node or block in the blockchain owns a full copy of the blockchain. That's why we are saying it is transparent. And every block utilizes some computing power to constantly maintain the blockchain. So it is not like that every node is sitting idle and just having a copy, but every node is making some contribution and maintaining the blockchain. What contribution? Performing computations, or that means recording the transactions and verifying the transactions. So in this slide, it will be much more clear the working of the entire blockchain. So we should understand that what happens when or how blocks are formed and what happens when a transaction is occurring, how it is entered to the blockchain. So here's the sequence of activities. Let's say once transaction is requested, let's take an example that party A is transferring some amount to party B. And that what happens then, that request or that transaction is broadcasted to all the peers in the peer-to-peer network. That means to all the nodes. So that means it is a broadcast, or whatever whenever a transaction is executing, it is sent to each and every node in the network. And then what happens? The validation starts. Validation of transaction. The nodes in the network validate the transactions. So that means the validation of transaction is done by the nodes itself. And once verified, it can involve any digital asset. And after verification, what happens? These transactions are put into a new block. Let's say, for example, 5 or 10, a group of 5 or 10 transactions occurred, and they are being validated by some different node. And then what is happening after when those 5 or a group of 5 or 10 transactions are, or verification of those 5 to 10 transactions are complete, they are combined into a single block. And that single block is now a new block in the blockchain, and it is being added here as a part of blockchain. So only verified blocks are added to the blockchain, and verification is important because so that no fake transaction or block is entered to is entering to the blockchain, that we have to ensure. And then we will say the transaction is complete. So starting from a requested transaction and until when the block is added to the blockchain, we will say the transaction is not complete in fact. Now the question comes, what was the need of having such kind of system? And that we can understand why blockchain came into the picture is due to the problem of double spending. So what is double spending? That we'll understand here. First, let us take the example of physical currency. Like, say, for example, this is a $10 note and physical currency. It is very simple to understand. Let's say, for example, Bob wants to purchase some books from Lisa. What Bob does, Bob hand over this physical currency to Lisa, and as an exchange, Lisa provides some books to Bob. And in this case, we will say that a transaction is complete. There is no problem at all when we are talking about physical cash. This is first scenario. Coming to the second one. Now, let's say Bob has to accomplish the same task. That means Bob wants to purchase some books from Lisa using some digital currency. Now, digital currency means the currency which we can store electronically on our systems. So when we are changing this currency into a digital currency, what can happen? Let's say, for example, Bob now becomes greedy, and what he does, instead of directly sending the whole currency to Lisa, he creates another copy of that digital coin. So copy of digital coin he has created. So what Bob does, one copy of digital coin he is giving to Lisa for purchasing some items, maybe books or anything else. And another copy of digital coin Bob is giving, or Bob is sending to Alice to purchase some different item. Now, this is the problem of double spending. That means in that case, we will say that Bob has spent the same currency twice. First is this transaction, second is the transaction between Bob and Alice. Now, a simple solution to this problem. That means obviously one currency cannot be used twice. So what is the solution? Central authority. That means if there is a third party in between, who can verify the transaction whether this currency has been already spent or not, then the problem can be solved. Bob now, if in case of digital currency, so what will happen if Bob is spending his digital currency to purchase some books from Lisa, then that transaction is going to be recorded by the central authority in the form of a ledger. Now, obviously, when Bob wants to reuse that currency, he cannot do that, because in that case, the central authority will verify, okay, Bob has already spent this currency, how he can reuse it. So that is the solution to the problem. But again, the question is that maintaining central authority is costly. Because if we talk about, like, say, bank, whenever, like, say, two persons or two entities are transacting using a bank website or bank portal or using bank accounts, then bank is charging some amount. And in addition to that, maintaining banks, a lot of huge infrastructure, or can say huge number of infrastructure in terms of manpower, in terms of computing systems, those are necessary. And that's why these maintaining these central authority is very costly. So the question here comes, can we solve double spending problem without using the central authority? And the answer is yes, we can do that. And the solution has you can say the first time the solution to this problem or double spending problem has been given by this digital currency, Bitcoin. So Bitcoin has been, why it has evolved? Due to double spending problem. If we talk about the birth of Bitcoin, in 2008, Satoshi Nakamoto proposed a paper, a white paper, which is titled as a peer-to-peer electronic cash system. Because earlier to that, there was cash systems in 1980s, but he evolved one system that solved double spending problem with anonymity. That means the identity of the users was not known to anybody, or say, for example, if I am transacting, that my identity is not disclosed. And what is the best example of anonymity? In today, if we talk about today, Satoshi Nakamoto holds 19.4. That means he holds bitcoins of this particular quantity. That means $19.4 billion bitcoins he is already having. But nobody knows the identity of Satoshi Nakamoto. That means this person has been unseen. Now, this is the beauty of the system. The person who developed the system and who is having some amount over the blockchain system or network, the identity is not known. And this has been the first successful implementation of blockchain. So that means the platform that was used to implement Bitcoin is blockchain. And it fulfills these requirements. First, it is public ledger. That means this ledger or the entire copy of Bitcoin blockchain is available to all the nodes in the network. It is tamper proof. It cannot be changed. Nobody can tamper it or change the content of the blockchain. Anonymity, that means identity of the users was preserved. And last is reduced size of the blockchain is very, very less. Even today, if you want to store the entire copy of the blockchain, you can store onto your system. It is around few GBs, few tens of GBs. I think 20 GB around it will be the size. I think 2 years back I checked, I think it was 15 GB. Maybe it has increased to some extent. So these are the features of Bitcoin. Now, coming to the concepts of public key cryptography, because these are important to understand the whole process of blockchain. Because if we talk about keys in blockchain are managed using public key cryptography, specifically elliptic curve cryptography. We are using elliptic curve cryptography to generate public and private keys. So if we talk about public key crypto system, public key crypto system is also known as two key crypto system or asymmetric cryptography, where a pair of keys are used by each and every party to communicate. Let's say, for example, there are n parties in communication. So every party should be having a key pair in which one is private key, one is public key. Public key is public to all, or it is known to each and every node in the communication, while private key is to be kept with the party itself. It should not be disclosed. So if we talk about public key, it can be used either to encrypt messages or verify signature. So that means if we talk about uh, features of public key cryptography, it can provide confidentiality, it can provide authentication, it can provide integrity, it can also provide non-repudiation, it can also provide access control. So if we talk about all these features, no other cryptographic mechanism like symmetric cryptography earlier we were using, uh, those were able only to provide confidentiality, but rest of the features are not included in that, and that's why public key cryptography has become common. So two keys have to be maintained by each and every party. One is public key, second is private key. Private key is used to decrypt the messages or to sign the signature or creating the signature. So what is the meaning actually? uh, there are two important functionalities: confidentiality and authentication. So it depends that how which particular function we want to implement. If we are going to implement confidentiality, then we will be using public key to encrypt messages, and if we want to perform authentication, then we will be using private key to perform uh, encryption. Private key for encrypting the messages. Now, coming to the details of it, that how we can use public key cryptography to achieve authentication first. Let us understand with this diagram A. Let's say we are having a source and destination. Uh, let's say Alice on A and B, or Alice or Bob. Source A is generating some message X. And what we have to do, we have to authenticate this message, or this message should be authenticated by party B. So what should be the process? This message which is generated by source A must be encrypted by some public key encryption algorithm using private key of itself, because we have already discussed that when we want to perform authentication, we have to sign the message using private key of the party. So PRA is the private key and PUA is the public key of source A. Similarly, PRB is the private key of source B and PUB is the public key of destination B. So here we are using the private key of party A in order to encrypt. And let's say why the ciphertext or encrypted message. When it is reaching to the destination B, then it is decrypted using public key of party A, PUA, not public key of B. The reason is once the message is successfully decrypted by using the public key of A, it is ensured that, okay, yes, this particular message was encrypted using private key of source A. And that's why we will say that message X is authenticated. So here, let's say, for example, Bob wants to send $10 or want to send a message to Lisa. Then what he should do, he should sign by its own private key, so that can be validated by Lisa using Bob's public key. This is first one. Second one is confidentiality, how we can achieve confidentiality feature using public key cryptography. If we want to achieve confidentiality, that means we want to encrypt the message, not sign it. Then what we'll do, we will encrypt the message X using public key of the destination. So PUB here is the destination public key, which is available to all the parties. So it is also available to A. And then we are encrypting it. And then that message is decrypted at the receiving side using private key of party B, that is PRB. Because these two key, how these keys are created in public key cryptography, we are talking, actually we talk about a key pair. Why key pair? That, and let's say K1 and K2 be the public key pair for a particular party. So any of these keys can be used for authentication, for encryption, and any of these keys can be, or the other key can be used for decryption. So one key K1, if K1 we are using for encryption, then K2 will be used for decryption. If we are using K2 for encryption, then K1 will be used for decryption. So these are generated in that way, and that's why uh, both the functionalities can be implemented using public key cryptography. So this is just an example. Let's say Bob wants to send a confidential message or wants to encrypt the message, not sign it. So what he will do, he will sign this message or he will encrypt this message using Lisa's public key. So that, because we have said that once the message is encrypted using public key, it can be decrypted using the private key. So that is the logic. Coming to the concept of hash function here, hash function plays a very important role if we talk about blockchain, because we have discussed the architecture of a particular node or the structure of the node. Nodes are chained or blocks are chained using hash functions. So hash code are basically uh, generated by hash functions, which takes variable length data as input and produces a fixed length hash code, like here. So what is the role of hash function or hash code? Any arbitrary length message can be provided as input to the hash function. And what is done by hash function? Hash function maps this entire message into a fixed length hash value. So let's say small h be the hash code. Capital M, we say it is the message, original message. So h is equal to hm. This is the mathematical representation. That means input is m. We are applying capital H is hash function. The output is small h. So m is nothing but a variable length message or data. Capital H is the hash function, and small h is nothing but the fixed length hash code, or it is also known as message digest. So basically, what we are doing, we are mapping the arbitrary size data or variable size data to a fixed length hash code. And for what we are using, why we are using it? To provide integrity. How integrity can be ensured if we are using hash code? So that we can understand, okay, by this particular diagram. So here in this diagram, you can see that when a message M is generated by source A, then we are applying any hash algorithm like SHA-256 that Bitcoin uses. Hash function is applied to this message, and then the hash function and along with the encrypted value, that means the original message and its hash function, they are encrypting using some key k, and they are being sent here to the receiving side. And receiving side, here we have assumed that encryption and decryption is performed using symmetric cryptography using the same key. So at the receiving side also, this key k is used to decrypt the message. So obviously, what we have sent, the M and the hash code. So this message M and plus the hash code has been received, or it has been recovered here at the destination B. Now what happens after recovering the message plus the hash code? Destination B again recomputes the hash code of the message. So what is the advantage? Let's say this is now HM dash. This is some other hash code, and now these two values will be compared. If this new computed hash code is same as the received hash code, then the message is, we say that the message is validated and the integrity is assured. That means there is no change in the message. Why we are saying so? Because this hash function is designed in a way that if you provide any 1-bit change in the input, that will change many bits of the output. And that's why if the message has been altered in transit, then obviously the hash code of the message will change. And that's why we are recomputing at the destination side. The sent hash code should be matched with the recomputed hash code, and then the integrity can be ensured. If we talk about hash function, few properties must be satisfied here. Like number one is variable size input. That means hash code can be applied to a block of data of any size. We have seen in the definition also. Fixed size output, that means H produces a fixed length output. That means any arbitrary size message can be should be mapped to a fixed length hash value. Efficiency means HX is relatively easy to compute. That means so that hardware and software implementations are practical. One-way property says that for any given hash code, it is computationally infeasible to find the message y such that hash code of that message is equal to the given hash code. So that means it is one-way property. That means if message is given to you, then you can find out the hash code. But if the hash code is given to you, you cannot deduce the message. Weak collision resistance, this property says for any given block of X, it is computationally infeasible to find out the same message so that, different message which can produce the same hash code. That means what it says that hash code for any two messages must be different. It cannot be same. Strong collision resistance says given a pair of messages XY, you cannot find HX equal to HY or vice versa. If HX is equal to HY that is given to you, you cannot find a pair X and Y which holds this particular condition. So these are the properties which are satisfied by hash function. So whenever we are designing the hash function, or it should be ensured that all these properties should be satisfied. So if we talk about Bitcoin uses 256 SHA-256 hash function. SHA is a secure hash algorithm. So output here is a 256-bit hash code. So that means any input you are providing to this algorithm, SHA-256 algorithm, the output is 256 bits, that is 32 bytes as the hash code. Coming to the concept of mining, what is actually mining? Mining, simply speaking, is creating a new block. That means if you have created a new block in the blockchain, that means you have mined the block. But if we talk about, like, again, we have already seen this, that block should be mined using data and timestamp, the previous hash of the block and the hash of the current block. But we are saying it simply, but it is not that simple. Mining is very, very time consuming and difficult task, difficult in sense of computing power. It requires a huge amount of computational power actually. Why it is so? Because the concept behind, if we talk about Bitcoin blockchain, the concept has been taken from proof of work. That means proof of work is a mechanism that that shows how we can mine a particular block, and we'll see here in proof of work that why it is required and how we can ensure that the correct blocks are going to be mined actually. Because mining, if we talk about mining, if it was a very simple task, then everybody is going to mine the bitcoins and earning money, but it is not that much easy. We have already seen that blockchain is nothing but a list of blocks, and every single block has to be created and then added to the blockchain. Created, that means obviously first you will create the block, and creating block is not easy. We have seen that you have to verify, you have to create the transaction, you have to verify the transactions, and then you have to validate the transaction, validate the complete block, and then only the block will be added to the blockchain. So if we talk about adding the block to the blockchain, we must assure that before adding a block to the blockchain, it should be legitimate. It should not be fake actually. It has the correct transaction. No fake transaction should be there inside the block, and it has having the correct data inside it. That means the data should be accurate. It should not be tampered or modified. Without correct data and transaction, obviously the blockchain will be fake, and nobody is going to trust on that system. And that is why we are saying that every time we are creating a new block, we have to first make sure it is a legitimate block or it is a fair block by mining it through proof of work. That means mining behind, if we talk about Bitcoin blockchain, now there are different methods of mining, or you can say different methods of consensus, in fact. So here, if we talk about Bitcoin blockchain, it is using proof of work. So that's what we are discussing here. So proof of work method is utilized to verify and add a particular block into the blockchain. So let us see more about what is POW. So To conceptually describe this, let us understand that there is a network server and few nodes in the system. So what happens in proof of work? Actually, network server sends a puzzle. This puzzle is a cryptographic puzzle. It is based on some sort of hash functions, maybe. Uh, a cryptographic puzzle is sent by the network server to different participants. Let's say, for example, that x1, x2, x3 are potential miners. These are the three miners. And when network server throws the puzzle, let's say y is equal to fx and find over to the value of x. You have to find out. When this puzzle is received by all these participants or nodes x1, x2, and x3, they are guessing or they are computing the solutions for this particular problem. Let's say, for example, y is equal to fx1. X1 is proposing the solution, y is equal to fx2 is the solution proposed by node x2, and y is equal to fx3 is the solution proposed by node x3. Now let's say, for example, this node x2 solve this puzzle correctly. So what will happen? He will have the opportunity to mine the blocks and he will be rewarded for that. So that means, because the reason why, what is the reason behind it? Reason behind it that solving this cryptographic puzzle is not an easy task. You have to perform again a lot of computation, and you have to involve your time also and computing power also. That means you have to put a lot of resources, and resources are not free. They're obviously you have to pay for them. Computing power, maybe high-end servers you require, high-end machines you require, and then you can try to solve this problem. And even many of the nodes are failing, and only a few nodes are going to solve this cryptographic puzzle using a lot of computational resources, and then only you are going to be rewarded. And in that case, you will say that yes, I have mined a block in the blockchain. So once you have mined a block, then only it will be added to the blockchain. So now the question comes that how proof of work method actually ensures that there is a correctness feature in the when we are adding the block to the blockchain. So how this POW or proof of work method actually secures the blockchain? There are a few reasons that, which are listed here. Number one is requirement of the huge amount of computational power. Because if we talk about, everybody cannot do that. So in order to solve cryptographic puzzle, you require huge amount of computational power and resources. Second reason is to create an already existing block or remining it with fake data is computationally infeasible. Why it is infeasible? That means computationally infeasible we talked about. That means it will take a huge amount of time, number of years, to remine each and every block. So it is not feasible. That means you have to just recreate the whole blockchain. That is totally infeasible. And third is, if we talk about all the blocks are linked by hash code, we have seen. And if we want to remine an existing block, that means, say for example, I want to remove one block and I want to add my own, or by remining it. So what we have to do, what I have to do, let's say for example, there are 1000 blocks and I want to mine 500 first block. So what I have to do, 500 first onwards, 1000 block, I have to remine. All the blocks should be remined because they are connected with the hash code. Because whatever, if we have seen this, if I am going to make even 1 bit change in the hash code, or you can say the actual data, the entire hash code is going to change. And that is the reason, if you are creating one fake block, then you have to recreate all the further blocks, which are again computationally infeasible. And that is why for a well-developed blockchain, all these things are not possible or infeasible. That means you cannot recreate or remind the blocks. And that is why we say that proof of work is actually very secure one. And that's why we say that blockchain technology is so secure. Now there are many mechanisms. Proof of stake is also there, like that is used by other systems. We are discussing about Bitcoin here. Next concept comes up for Merkle tree. What is the reason of reduced size of the blockchain, because we know that number of transactions are rapidly increasing. If we talk about Bitcoin network or Bitcoin blockchain, every day there are huge number of transactions that are occurring. So what is the reason why we are saying that the size of blockchain is reduced? So the reason here is using the Merkle tree representation. So what is done using Merkle tree? All the transactions in a block are hashed, and then they are represented by a particular root hash. Like, say, for example, in this diagram A, we can see that transactions are there, tx00100101021003. Now, in the top, or you can say it's some sort of binary tree representation where we are providing the hash code for each and every transaction. So this is the first hash code, second hash code, like one more hash code, one more hash code. Now, in a hierarchical tree manner, which is known as Merkle tree, we are representing the roots, and these roots are nothing but hashes. So again, this hash 100101 is the hash code of these two children. This hash code is again this hash 102 and 103 is a hash code of these two children. And similarly, now finally, the root hash is computed and stored within the block along with the previous hash and none. So actually speaking, we are not actually storing the actual transactions within the particular block. What we are including only the hash of these roots, which is known as root hash. Because we know that if we talk about hash code, the properties of hash code we have seen, any arbitrary size message can be converted into a fixed length hash code. And that is one reason the limited bits are required to represent the entire tree which is below, and that's why the size of, or the represented size of a block is very less, and so for the blockchain. So that is the one reason that why the blockchain size is very less, and that this is the main reason. Merkle tree structure. So this is just an example that has been shown here. You can see the Merkle root in every block. We are having the Merkle root, not the actual transaction, but these Merkle roots are root hashes actually. Coming to the cryptocurrencies, if we talk about cryptocurrencies, there are a lot of cryptocurrencies that we have seen. So what are the features of cryptocurrency actually? Number one, they should be digital currency. Digital means like one are physical cash, which are having dollars or notes. But this digital currency which that we can store in our wallet, electronic wallet. Like if we talk about Bitcoin and Ethereum, many cryptocurrencies are there. Bitcoin, again, if you want to purchase any of the any of that digital currency or cryptocurrency, you have to maintain your wallet, e-wallet, where you will be assigned private key and public key. Public key can be used by it is available to all the parties in the communication, and private key you will be holding, which is to be kept private, and you can access your wallet using your private key. So that is the thing. And digital currency, that means should be digital one. That means you can store it on a particular application or computer system. Decentralized. Decentralized, this is very important, that we have again discussed, already discussed, that decentralized means it is not controlled by a single entity. Like, say, for example, Bitcoin blockchain. What is the fundamental reason? If we talk about the popularity of Bitcoin, it is not controlled by any country or the government of any country. It is decentralized. That means a person who is sitting in USA can also purchase a Bitcoin. We are sitting in India, maybe we can also purchase a Bitcoin. So, and since they are not controlled by a single authority, that's why they are decentralized. Another is peer-to-peer. Irrespective of the locations, geographic locations, the diversities, and cross borders, even you can use digital currency to make transactions. So any two parties in the network can transact without any hindrances. That is peer-to-peer. Pseudonymous. Identity is not known to anybody. If two parties A and B are communicating, their actual identities will not be known. Only public IDs will be there, which will be used, but actual ID you cannot know that who two persons are going to communicate. And that is the biggest reason that why government of many countries are discouraging these cryptocurrencies like Bitcoin, because they want to say a huge transaction is occurring, or then they want to, governments want to track that how much money has been transferred to which particular party, because a lot of issues are there for the government. So that's why they are discouraging, because they cannot know the identity of any person who is making a transaction. Trustless. Trust is not required between the parties. Why trustless we are saying? This is a very important keyword. Why trustless? Because like say for example, I want to transact with the party B. So actual identity is not known. But what I want, I am going to trust on the system, not the party, because I am not going to authenticate anything. But what I am relying on, I am relying on the system. I am trusting on the system, not the party itself. That's why we are saying it is trustless. Encrypted, yes, the transactions are obviously hashed, so in that way we can say it is encrypted. Global, which can be used anywhere or in any country or any particular region. So these are the features of cryptocurrencies that should be there. And if we talk about Bitcoin, we take the example of Bitcoin. If we see Bitcoin, Bitcoin satisfies all these features. Bitcoin, it's a digital currency, it is a decentralized one, it is a peer-to-peer, it is based on peer-to-peer network, pseudonymous, trustless, encrypted, and global. So these properties must be satisfied by each and every cryptocurrency. Next is cryptocurrencies only exist on the blockchain. Blockchain is the fundamental behind implementation of each and every cryptocurrency. And this I have already told that users access their cryptocurrency called public and private keys. So these are few examples of cryptocurrencies: Bitcoin, Ripple, Monero, EOS, Ethereum, Litecoin, Libra, Ether, and many others. So I think more than 50 you can find over the internet. These are few very famous ones. Everybody is aware of Bitcoin today and Ethereum today. Litecoin is also famous. Ripple is also famous. So, but the fundamental behind each and every cryptocurrency is same. All these features, and they are practically possible using the blockchain. So to summarize this, what we have discussed or understood, that blockchain is immutable and distributed ledger. There are a wide range of applications of blockchain which are possible, because we have discussed that if we talk about blockchain, fundamentally speaking, it can replace any distributed system actually, or any decentralized distributed system can be replaced by blockchain. Bitcoin has been the first successful implementation of blockchain, which is a financial one. Security of the blockchain is based on two important things. One is public cryptography and hash codes. Because public cryptography, again, I will repeat this. Public cryptography is used to manage keys, public and private keys, and hash codes are used to link the hash code, link the sorry block, link different blocks in the blockchain network. Mining and proof of work lead to reward. So if you are so POW is basically consensus mechanism. Consensus actually it is a mechanism just to arrive on a particular decision. If so many parties are involved, then how to arrive on a particular decision? That is a fundamental problem. Because in centralized system it is comparatively easy, because in centralized system central authority is making all the decisions. But if we are on a peer-to-peer or public network, then to decide what should be the next step, what decision we have to take, so that is based on the consensus. So there are many consensus algorithms. Proof of stake is there, proof of work is there, hybrid mechanisms are there, many are there. And we have also seen that blockchain takes less space due to the usage of Merkle tree structure. So the fundamental reason behind the less space taken by the blockchain is Merkle tree. And we have also seen that many cryptocurrencies in the world have evolved and you can say at a very fast speed. We can see a lot of cryptocurrencies has evolved. So this is from my side for today's session. Any queries are there? If ma'am, you can assist me for handling queries. Thank you.
Thank you, sir. Thank you so much for this very nice session.
Thank you, ma'am.
If anyone has any question, you can ask. I think no one have any questions, sir.
Okay, ma'am.
Thank you so much all the participants for your active participation. Let me inform to all that this complete session will be available on our Research Circle YouTube channel. So if you want to watch it again and want to share it somebody, please do visit the Research Circle Business Rozgar YouTube channel. Thanks. And last but not the least, thank you, Dr. Anuj Kumar Singh sir, for taking out time for session. With your permission, I would like to the end today's session here. Thank you,
Yes,
sir.
yes. Thank you, ma'am. Thanks a lot. Thank you.